Hi everyone, we're going to do a different kind of proof by mathematical induction, or a different kind of problem actually. We're going to prove that 3 to the nth power minus 1 is divisible by 2 for all natural numbers n. So this is my n. And there's a little algebra trick involved with it, and that's basically what I wanted to show. Because if you don't know the algebra trick, then you can't do these. We have to show that it holds for the first natural number of 1. And let's see what happens there. We get 3 to the first power minus 1 equals 2. So you ask yourself, is 2 divisible by 2? Yes. So this one's a different kind, and that's true. So now we want to see if it holds for k plus 1. So we're going to rewrite, we're falling for this. So we're going to do, change the n to a k. Alright, and now we're going to check for 3k plus 1, the next term. And so let me show you the little trick we're going to do with that. There's not much you can do with that if you look at it. Is that divisible by 2? It's hard to tell. So what we're going to do is rewrite it as 3k plus 1 minus 1 equals 3 to the k plus 1 minus 3k plus 3k minus 1. So what did I do? I kind of just added some fluff here. You know these two equal 0. But when I do that, I can kind of do this factor by grouping, and I can write this as 3k to the 3 minus 1 plus, and I'm just going to copy him down, 3k the minus 1. And as I showed in a previous video, if you multiply 3 times 3 to the k, that equals 3 to the k plus 1. So as long as you know that, we're good to go. And if you plug in some values here, you can tell. If you let k be 2, then we have 3 times 3 times 3. And then here, if you plug in 2, that would be 3 cubed. So they both equal 27. So just kind of know how to do this. It's good for your SAT exams as well. Anyway, we already talked about that in a previous video, so we're going to move on. So if you don't know that, you might want to look at video part 2, and that will help you, the mathematical induction. Now what I'm going to do is clean this up. So this would be 3k times 2 plus 3k minus 1. Now I'm going to clean it up further, and notice that since we already know that this is divisible by 2, right? We already proved that this is divisible by 2 because I plugged in 1, and when I plugged in 1, we got 3 to the 1 minus 1 equals 2. So 2 is divisible by 2. So we know this part's divisible by 2. This is as well divisible by 2 because you have a 2 here, and that can divide by 2. So basically, since it's divisible by 2, they both are. Condition 2 is satisfied. It's just a different way of looking at it than the ones we did before. So the statement 3 to the n minus 1 is divisible by 2 is true for all natural numbers n. Now let's try a couple more just to make sure we get the hang of this. Let's try this one. We have n squared plus n is divisible by 2. So this one's actually shorter to do. You don't have to worry so much about putting all that the longness of the other ones. So what we're going to do is check for 1. I'm going to put 1 squared. This is our condition 1. We're going to check for n equals 1. 1 squared plus 1 is 2. Now, is 2 divisible by 2? Yes. So condition 1 holds. Now we're going to check for condition 2. and we're going to change everything to k squared plus k. Is this divisible by 2? When we check for, we're going to check for k plus 1. So basically, we're going to write in k plus 1 squared. Everywhere there's a k, I'm going to put a k plus 1. Okay, and going to clean, I don't need the parentheses here, but I'm going to clean this up and factor. So this would be k squared plus 2k plus 1 plus k plus 1. Now clean it up. Plus 3k plus 2. And then we're going to go ahead and factor. This would be, no, I'm not going to do it that way. What I'm going to do is just look at it like this. I'm going to look at this. K squared plus 2k plus k plus 2. All right? And I'm going to group these two together. So that's going to be k squared plus k plus 2k plus 2. Now, we already know that this is divisible by 2 because we already checked it here when we checked for condition 1. Is this divisible by 2? Yes, this is divisible by 2 because I can factor out a 2 and I get k plus 1. But can you divide this by 2? Yes. So it's divisible by 2, and conditions 1 and 2 are satisfied, so the statement is true. It's a little different way of doing it than we did in the previous videos. So before we factored them together, or put them together like I tried to do, and you're trying to really keep them separated apart, just keep in mind what the goal is. So let's do another one. We have n cubed plus 2n is divisible by 3. So I'm going to check for condition 1. Plug in 1. You get 1 cubed plus 2 times 1. That equals 3. Is that divisible by 3? Of course it is. 3 can divide itself. So it's true. So we're going to check for 2. We're going to be checking for k plus 1, but I'm going to put the k's in first and check if it holds for all natural numbers. So I'm going to get k plus 1 cubed plus 2k. Now, how are we going to arrange this so we can divide this by 3? So what I'm going to do is go ahead and use my properties, the a plus b cubed thing out, and I'm going to write that out. That equals a cubed plus 3, oh not a, we're using k, sorry. So this is going to equal k cubed plus 3k squared plus 3k plus 1. And basically, you're going to have to, if you don't know Pascal's triangle or your binomial theorem, you're going to have to write this out 3 times and FOIL it all out, and you'll get that, plus 2k. Now, let's see. I'm going to go ahead and group a little bit. I have a 1 plus, oh, I forgot to put the k plus 2. This should have been 2k plus 1 here. So that's going to be 2k plus 2. All right. So this part is here, and this is this part. Well, let's put some things together. I'm going to rewrite this as k cubed plus 3k squared plus 3k plus 2k plus 3. Now what I'm going to do, since we're trying to see if it's divisible by 3, I'm going to group everything with the 3 in together. So I'm going to put these two guys together, because we already know it looks like that. So we have k cubed plus 2k. We already know that's divisible by 3, because we already proved it here. Then I'm going to group these together, my 3's, and write plus 3k squared plus 3k plus 3. And when I factor out of 3, I get 3k squared plus k plus 1. Now, is this divisible by 3? Yes, it is. So we already know this is divisible by 3. This is divisible by 3. So since they're both divisible by 3, condition 1 and condition 2 hold. So it is a true statement. All right. These kind that we just got through doing take a while to get used to. You have to look for example, like we did, you have to look for the 3's here. And you also want to rewrite it to include what we started with, because we already know that that happened. We can try one more. Let's try, this one looks scary here. So we have n squared minus n plus 2 is divisible by 2. This will be the last one. So we're going to check for condition 1. You know that always should be true. So we're going to have 1 squared minus 1 plus 2, which equals 2. Is 2 divisible by 2? Yes. Okay. So when we're working this out, what we want is to get this back and then something else that we can divide 2 by. So let's change everything to k for condition 2. So we have k squared minus k plus 2, and now substitute k plus 1. All right, now when I factor this out, I'm going to get k squared plus 2k plus 1 minus k minus 1 plus 2. And I hope I did everything right. So now can I write anything that looks like this? So I have a k squared here, a minus k here, and a plus k here, or the plus 2 here. So I'm going to copy that down, k squared minus k plus 2, because I already know that's divisible by 2, because we already said it was. We already checked for k or n equals 1. What I'm left with is these 3 pieces. And all that is plus 2k, because the 1's will cancel. Is this divisible by 2? Well, yes, it's divisible by 2. So conditions 1 and 2 hold. These are actually fairly easy if you get used to knowing what you're looking for. And that's all.